Good afternoon, dear students. Yes. Yes, so in the previous class, we have discussed about the preparation of alcohols and phenols, right? So we have completed the preparations, methods of preparations of your this what alcohols and phenols. So today we are going to start with the physical properties, okay? Physical properties of alcohols and phenols. So let us see the physical properties of alcohol and phenols. So first physical property is we are discussing about the boiling point. Okay, so let us discuss about the boiling point of alcohols and phenols. Okay, so the boiling point of alcohols and phenols. Okay, so these are higher as compared to the organic compounds of uh, organic compounds which are having similar molecular mass. Okay, so when we are comparing the boiling point of when you're comparing the boiling point of your alcohols and phenols, so these are having, okay, the boiling point is higher, okay, as compared to the other organic molecule. For example, your hydrocarbons. Okay, if you consider your hydrocarbons and if you consider your alcohols and phenols, okay. So alcohols and phenols will have a slightly higher this what boiling point. What is the reason? What is the reason? It is due to the presence of. So when I write the structure of alcohols and phenols, so let me write here. So this is your alcohol and this is your phenol, right? So here, what you can see that. So if I take this as CH3, okay. So what you can see, there is a OH group. Okay. So when this, so it is due to, so why this alcohol and phenol, why the boiling points are higher? Because it is due to the intermolecular hydrogen bonding. Okay. It is due to the intermolecular hydrogen bonding. Okay. So you can see that there is an intermolecular hydrogen bonding in alcohols and phenols. Okay. And as you see in hydrocarbons, so if I, so this is an example of hydrocarbon, that is methane. So can you see any electronegative atom? Your oxygen is an electronegative atom, right? Present in the your alcohol group. Okay. So because of the presence of an electronegative atom in the molecule, okay, you can see that it can form intermolecular hydrogen bonding with the water molecules, right? But when you see this hydrocarbons and if you take ether, suppose if I take ether, so what you can see here, there is no OH, okay, linking cannot takes place. So there is a what hydrogen bonding formation is absent in case of your methane and your ethers. Okay, so this is the reason, okay, why the boiling point of okay, so this is the reason why it is having higher boiling point and okay, in case of alcohols and phenols. Now, if I compare the alcohol, so R, okay, O, then here is your H. So how? So in between the alcohol molecules, right? In between the alcohol molecules, you can see how the hydrogen bonding is forming. So this is the hydrogen bonding. Okay, so this is the hydrogen bonding. So let me write it like this. So H O R. Okay, then again O, then here H and R. H and R. Okay, like this. So like this. So this is what? This is a hydrogen bonding. So hydrogen bonding is present in between these alcohol atoms, right? Now, if you compare your phenols, okay, if you compare the phenols, so how the hydrogen bonding takes place, just see O, okay. Then, so here is one, so it is H. Then again, one molecule of phenol. So then it will be O, okay, so your H, then So like this is the hydrogen bonding, okay, between the, so like this hydrogen bonding takes place. Is it clear? So as compared to the alcohols and phenols, okay, they are having higher boiling point when you compare your hydrocarbons or ethers. So in ethers and hydrocarbon, there is absence of hydrogen bonding. Okay, so you can see in case of alcohols and phenols, okay, what you can see, there is a presence of hydrogen bonding. So they can undergo intermolecular hydrogen bonding. Okay. So this is the reason. So the boiling point. So what will happen to the boiling point? So as the number of carbon atom increases, okay, as the number of carbon atom increases in case of your this what alcohols and phenols, then the what will happen? The boiling point also will increase. Okay, the boiling point will increase. So as the number of carbon atom increases, so from methane, if it forms ethane, okay, then ethane, then if it forms propane. So as the hydrogen, as the number of carbon atoms are increasing, what is happening here? What you can see, what you can see, the molecular mass is increasing. As a result, the this also increases. Okay, boiling point also increases. So this is the one point. Okay, you have to remember. Then second thing is that if you have a isomeric alcohols. Now, what do you mean by isomeric alcohol? Suppose I have a butanol. Okay, I have a butanol. So consider one butanol. Then I have CH3, CH2, CH, CH3, OH. Then this is CH3, 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 OH. So this is a tertiary carbon, this is a secondary carbon, and this is a primary carbon, right? So you can see the number of carbon atoms in each case is what? It is 4 only, but these are the isomers of butane. So these are the butanol. So these are the isomers of butanol, right? So this is a primary alcohol, secondary and tertiary. Now when we are comparing the boiling point in case of isomeric, so this is a N chain. N chain means this is a straight chain compound, right? The first one is a straight chain compound, this one. Now here you can see what is happening, the isomers, okay, the chain, the branching is increasing, right? So as you see in secondary and tertiary, the branching is more, okay? The branching is more. So because of that, what happens here, you can see in case of isomeric alcohols, what will happen to the boiling point? The boiling point decreases. It goes on decreasing as the branching takes place. Okay. As so as the branching increases, what will happen to the boiling point? Boiling point will go on decreases. Okay. So why? Because of increase in branching, what will happen to the surface area? The surface area will decrease. So you can see how what is happening to the surface area because of branching. The surface area is decreasing. So therefore, the van der Waals forces. So the van der Waals forces are the weak forces. So they also decrease, and because of that, the boiling point also decrease. So if I give you the theoretical data about the boiling point, so in case of this a straight chain compound butanol, the boiling point is 391 Kelvin. In case of secondary alcohol, it is 337 Kelvin, and in case of tertiary, it is 356 Kelvin. So what is happening to the boiling point? Boiling point is going on decreasing. Okay, in case of isomeric alcohols. Okay, why? Because the surface area decreases, van der Waals forces decreases. Because of that, boiling point also decreases. Is it clear about boiling point? Yes, any doubt? Okay, fine. So let us go for the next one. Solubility. So next is what? Solubility. About solubility, we are going to discuss. So solubility, okay, when we are discussing about solubility, so what things you have to consider? Solubility means how the alcohols are soluble, okay, whether it is soluble in water or no. So that all things we have to see. Now, whenever you see the lower members of alkanes, okay, that is lower members of alcohols, okay, lower members of alcohols. So these are what? These are highly soluble. These are highly soluble in water. Okay. But what will happen to solubility? The solubility will decrease. So whenever you have lower alcohols, okay, whenever you have lower alcohols, consider that lower alcohols are highly soluble in water. Okay, they will be highly soluble in water. But as you are proceeding to higher alcohols, okay, so from carbon 1 to suppose I am moving for carbon 5. So that time what will happen to this? It will the solubility it goes on decreasing. Why? Because there is an increase in molecular mass. The molecular mass will be increased. Now here carbon is only 12 grams. Okay. Now when it is C5, okay, it will become 60 grams. So what is happening here? The molecular mass is increasing. So as the molecular mass is increasing, what will happen to solubility? Solubility will go on decreasing. Okay, it will go on decreasing. So with the increase in molecular mass, okay, with the increase in molecular mass, what will happen to solubility? Solubility will go on decreasing. Okay. So next we are going to and why the solubility is present in the lower alkanes. So because they can form hydrogen bonding. Okay, they can form hydrogen bonding. So because of this, so hydrogen bonding is possible. Okay, the stability it is due to their ability to form the hydrogen bonding with the water molecule. So because of this, the solubility is high in lower alcohols as compared to that of the higher alcohol. So this is the reason. Okay. So if I give you, let me give you example. Okay. So I'll give you some compounds. Okay. I'll give you some compounds. You have to arrange. Okay. You have to arrange in order of their increasing boiling point. In increasing boiling point. So let me give the compounds. The first one is pentane 1 all. Second one is butane 1 all. Third one is butane 2 all. Then fourth one is ethanol. Fifth one is propane 1 all. Sixth one is methanol. Okay. Is it clear? Okay. So now tell me how will you arrange these compounds in the order of their increasing boiling points? Yes, please arrange these compounds in their increasing order of their increasing boiling point. Now we know that, okay, as so lower alcohols will have higher boiling point. Okay, so as you increase the so alcohols, okay, with increase in what is that molecular mass, the this what boiling point goes on increasing. This is in case of straight chain alcohols. Okay, so boiling point goes on increasing. Now, when you are comparing isomeric alcohols with the increase in isomeric alcohols, what will happen? Increase in branching. The this what is that? Your alcohol boiling point goes on decreasing. So comparing the number of carbon. Yes. Can you arrange? Can you tell me the numbers? Yes. How will you arrange it in the increasing order? So see the considering the number of carbon, yes, but so for what will come first? Increasing means from lowest to highest. First will be your sixth, yes. Methanol will come first. Very good. So methanol will come first. So let me write it as 6. So sixth will be the lowest. Boiling point will be lowest in this case because it is the carbon atom is only one, CH3OH, right? Methanol. Next, next is what? Next is fourth one. Yes, very good, Pavitra. Fourth one. So next is ethanol. Fourth one is ethanol. CH3, CH2, OH. Yes, very good. Next. Yes, others also can try. So next will what? After ethanol, you have propanol, right? So next is propanol. So fifth one. Propanol is three carbon atoms, CH3, CH2, CH2OH. Propanol, right? Yes, propanol will come. Okay. And then will be your, after propanol, you have butane. Now butane 1-ol or butane 2-ol. Okay. First will be your butane 2-ol. Why? Because it is isomeric. Okay, so it will have a isomeric structure. So 1, 2, 3, right? 1, 2, 3, OH, butane. mm, So this is a isomeric structure, CH3, CH2, CH, CH3. So 1, 2, 3, 4. So butane 2-ol, right? So this will be your third one comes, then comes your second one, butane 1-ol, and then comes your pentane 1-ol. Okay. So this is the answer. Yes, 3, 2, 1. Very good. Yes, Pavitra and Devi has answered. Very good. Okay. So let us go for the next one. So like this, you have to arrange the compounds in their increasing order. Okay. So next we are going to discuss the physical properties of alcohols. Okay. So let us discuss now the physical, that is, we have completed the physical properties. Now let us discuss about the chemical properties. Okay, let us discuss about the chemical properties of alcohols. Okay, so we have seen the physical properties. Main two physical properties are boiling point and solubility. Next is chemical properties. So alcohols, okay, so they act both. They act as a nucleophile also, and they act as a electrophile also. Now, what is the role of electrophile and what is the role of nucleophile? Nucleophiles are electron rich, okay, and electrophiles are electron deficient. Okay, now here what happens? So what are the alcohols? So alcohols are the nucleophile. Okay, alcohols are the nucleophiles, and these are what? These are electron. So they will act. So alcohol acts as a nucleophile also, and they will act as a electrophile also. Okay. Now, if they behave as a nucleophile, so if alcohols behave behaves as a nucleophile then then OH bond is broken. OH bond is broken in a reaction. Okay, in a reaction. So how the OH bond is broken? So let me take. So this is our alcohol. So it is going to react it with the electron deficient because your alcohol is acting as what? Electron rich. So electron rich species will attack the electron deficient species. So we have taken a carbocation. So the attack will take place and how it will form. So R, O, okay, H, C. So like this, the attack will take place. Now after rearranging, so how you will get R, O, C, so plus H plus. Okay, so like this, the attack takes place. Got it? So like this, you are going to get the this what reaction. Okay, so chemical properties. How are the chemical properties? So alcohols, they can act both as a nucleophile also, and they can act as a electrophile also. So if alcohol is behaving like a nucleophile, if alcohol is behaving like a nucleophile, then OH bond is broken in a reaction. Okay, OH bond is broken in a reaction. So how the reaction takes place? So here the oxygen is electron rich, so rich species will attack the electron deficient species, and like this the product is formed. Okay, so this is in case of when alcohols are acting as a nucleophile. So this way the reaction takes place. So next is when alcohols are acting as a electrophile. So let us see. So when alcohols are acting as a electrophile, so let us see. So here protonated alcohol. So whenever you have protonated alcohols, protonated means what? When the H plus ions, okay, when they attack the alcohols, you get a protonated alcohol. So protonated alcohols, they act as electrophiles. Okay, they act as a electrophiles. So if they behave as electrophiles, so they'll behave as a electrophiles, then what will happen? CO bond will be broken. Okay, CO bond is broken. So in case of nucleophile, what bond is broken? OH. Okay, OH bond is broken. In case when alcohols are acting as an electrophile, then CO bond is broken. Okay. Now let us write the reaction. So let me write the reaction. So R CH2OH. Okay, so this is the alcohol. So these alcohol, when how it will get protonated when it attacks the your electron deficient hydrogen. Okay, that is a proton. So you get CH2OH plus. Okay, so this is your electrophile. So this is the electrophile which is formed. This is the electrophile which is formed. Okay. Now, next second step, let me write the second step. So now we have found the electrophile, right? Now we have got the electrophile. Then okay. So here, so now we have generated the electrophile in the first step. Now what we are going to do, we are going to attack this. What we are taking a Br minus. Okay, let me clear this. Okay, let me clear this Br minus. Then plus CH2OH plus and here R. So what will happen? Like this, the attack takes place, the bond is broken. Okay. So we know that the electron rich species will attack this carbon and the CO bond is broken. You can see the CO bond. So this is the CO bond which is broken and the new bond is formed between Br2, CH2 and R plus H2O. Got it? So like this the alcohol. So alcohol acts as what? It acts as both. It acts as a nucleophile also and it acts as a electrophile also. Okay. So when it is acting as a nucleophile, then what will happen? So the electron rich oxygen will attack the electron deficient carbocation. Okay. And you will generate a so their OH bond is broken. And in case of alcohols, when it is acting as a electrophile, so that time it will what it will you have to use a protonated alcohol. Okay, we have to use a protonated alcohol. So in case of protonated alcohol, what will happen? Which bond is broken? CO bond is broken. So here, so you have to consider this. Okay, so how the reaction takes place. So whenever alcohols are acting as a nucleophile, okay, the what will happen? OH bond is broken. When it is acting as an electrophile, then CO bond is broken. So like this, the products form will be different. Is it clear? So these are the chemical properties. So those the alcohols and phenols, okay, they are divided into two groups based on this. First is the reactions involving. So first is the reaction involving cleavage. Cleavage means breaking of bond of OH bond. And the second is reactions involving cleavage of CO bond. So based on the chemical properties, okay, based on the chemical properties, it is divided into two types. Okay, first is the reaction involving the cleavage of OH bond, and the second is reactions involving the cleavage of CO bond. CO bond means between the carbon and oxygen when the bond is broken. Okay, so these are the two types of reactions which takes place in alcohols and phenol. So let us start with the first, that is reaction involving the cleavage at OH bond. Okay, so let us start with that. Okay, so this is the reactions, chemical reactions of alcohols and phenols when the cleavage is taking place at OH bond. Okay, so when OH bond is cleaved, so here the reaction takes place. So where it takes place at OH bond. Okay, reaction involving the OH bond. So first is the reaction is with metals. Okay, we can do the reaction with what? Reaction is with metals. So let us do the reactions with metals. So how we will get the, so here, so alcohols and phenols, okay, they react with active metals. So they react with what? Active metals like sodium, potassium, aluminium, okay, magnesium. Okay, so these are the active metals and they will give corresponding alkoxide or phenoxide. So when alcohols, so alcohols, what we have to do? We have to react it with the active metals. Okay, we have to react it with the active metals and we are going to get what? Alkoxide. So these are the alkoxide. So this is a sodium alkoxide. So this is a sodium alkoxide and hydrogen gas is liberated. Okay, hydrogen gas is liberated. So this is a reaction with metals. So when you have reaction with metals, so this is the reaction which is formed. That is alcohols. When you react it with sodium, okay, what it forms? It forms a sodium alkoxide and hydrogen gas is liberated. So you can see a reaction, right? You can see the reaction. Okay, so this is the reaction with metal. So when, now suppose I have phenol now. If I take phenol, so phenol, if I react it with active metal like sodium, okay, what it forms? It forms sodium phenoxide. It forms sodium phenoxide. Okay, sodium phenoxide plus hydrogen gas is liberated. So this is the reaction. So phenol, when it reacts with active metal like sodium, it forms sodium phenoxide. And when alcohols, when they react it with active metals like sodium, it forms what? It forms sodium alkoxide. Okay, it forms sodium alkoxide. So very important reactions and with the liberation of hydrogen gas. Okay. So this is the, got it? Yes. So let us take examples now. Yes, let us take example. So here, what you can see, so in this reaction, you can see that the OH bond is broken. Now, where is this OH bond? Yes, students, where is the OH bond? This is the OH bond, right? So you can see that the OH bond is broken and ONA bond is formed. Here also you can see the OH bond is broken and ONA bond is formed. So this is the first type of reaction. where the breaking of bond takes place at OH bond. Okay, it takes place at what? It takes place at OH. Fine. So let us take an example. So if I take 2C2H5OH plus 2Na, what it forms? Yes. What it forms here? Yes, what is the product form? It is sodium ethoxide. The name of the compound is what? It is sodium ethoxide. Okay, sodium ethoxide is formed. Sodium ethoxide plus hydrogen gas is liberated. Fine. So this is the product. Now suppose if I have, here you can see 6 times, okay, tertiary butyl alcohol, 6 moles of tertiary butyl alcohol. When you react it with active metals like aluminium, what it is formed. So here the OH bond is broken, okay, and it is substituted by OAl, okay, thrice plus 3H2 gas is liberated. Okay, so this is the reaction. You can see the reaction. So whenever you have active metal, so where the bond takes place, the breaking of bond takes place at OH bond, and it is forming a sodium alkoxide or sodium phenoxide as the product. Now here you can see with phenol, when you are reacting the phenol with the active metal like sodium, what you get? Sodium phenoxide is the product and hydrogen gas is liberated. Okay, fine. So next we are going to discuss about the acidity of alcohols and phenols. Okay, next is acidity of alcohols and phenols. So when we are discussing the acidity of alcohols and phenols, so what we have to see the acidity. Okay, the acidity of alcohol, it depends on what? It depends upon the polar nature of OH bond. Okay, that is due to the presence of this electronegative atom. Okay, due to the presence of this electronegative atom, that is oxygen. Okay, what it is doing? So because of that, it is a polar, so it will tend to pull the electron towards itself, right? So there is a polarity on ROH group, so it will tend to pull the electron towards itself. So the acidity of alcohols, it will depend on this polar nature of this OH bond. So what you can see here, the OH bond, how it is broken? It is broken heterolytically. Okay, it is broken heterolytically. Suppose I have this ROH, how it breaks? It breaks into RO minus plus H. Heterolytically means what? Suppose I have, so here you can see this is also a polar molecule. Right? This is also a polar molecule. So due to the presence of electronegative atom, what it will do? It will tend to pull the electron towards itself. So as a result, there will be partial negative and partial positive charge. Okay. Now, because of that, because of the presence of partial positive and negative charge, what will happen here? Yes, what will happen? The bond, when you are breaking the bond, so hydrogen will be left with no electrons and chlorine will take the pair of electrons with it. Okay, so like this, the heterolytic cleavage is formed. Now, what do you mean by homolytic cleavage? Suppose you have same atoms. Okay, suppose you have same atoms, so the distribution of electrons is equal. So this is called as homolytic cleavage. Heterolytic means unequal sharing of electron takes place. So whenever alcohols are there, okay, what it will do? It will undergo a heterolytic cleavage. Okay, it will undergo a heterolytic cleavage. Understood? Yes. Okay. So now when we are discussing about, so what is formed? It is a alkoxide ion is formed. So this is a alkoxide ion and a proton is released. Okay, a proton is released. So this is the case of your alcohols. Now suppose you have phenols now. Suppose you have a phenol. So phenol will form what? Phenol will form a phenoxide ion. Okay, it will form a phenoxide ion and a proton is released. Okay. So here you can see that the hydroxy group is attached to a sp2 hybridized carbon. So this is a sp2 hybridized carbon of the benzene ring, and this OH group is acting as an electron withdrawing group. Okay, it will withdraw the electron towards itself. But in case of alcohols, the hydroxy group is attached to alkyl group and it is acting as an electron releasing into effect. Okay. So because of that, so this is the ionization which is formed here. You can see. Okay. So here OH group, it will form phenoxide ion and a proton is formed. Got it? So this is the acidity. So this is the acidity of alcohols. So but when we are considering the alcohols, so if you are taking alcohols, okay, so this is the reaction. Let me show you. So when alcohols, when it reacts with a base, okay, when alcohol, so OH, what will happen? So the bond breakage will take place between the OH, so it will form a conjugate base and a conjugate acid. So this is your acid, this is a base, this is its conjugate base, and this is its conjugate acid. Okay. So what is this conjugate acid? Yes, conjugate acid means it contains one more hydrogen atom. So conjugate acid, it contains one more hydrogen atom. Okay. And so you can see more than the base, one more hydrogen atom is present. Okay. And charge is also more. And what is conjugate base? Conjugate base, it contains one hydrogen atom less. Okay. And one more negative charge than the acid which is formed. So you can see there is a negative charge developed from the conjugate base. So this is the conjugate acid and conjugate base. Now, when alcohol, when your base, that is your RO minus plus your acid, if I take water. So if alcohol is weaker acid than water. So why the alcohols are weaker acid than water? Because okay, water is a better proton donor. So water acts as a proton donor than the alcohols. Okay. So alkoxide ion is a better proton acceptor. So this will accept a proton. So because it is a better proton acceptor than your OH ion. So because of that, it indicates that alkoxide ions is stronger base. So alkoxide ion is a stronger base. So sodium methoxide, we are comparing the sodium methoxide. So sodium methoxide is a stronger base. Okay, it is a stronger base than your NaOH. Than your NaOH. So this is the theory behind why alcohols is weaker acid than water. Okay, so this is about your alcohols. So is it clear up to here? So esterification and other reactions. So let us see in the next class. Any doubts up to here? Yes. So we have discussed about the physical properties. Okay, we have discussed about the physical properties. Two physical properties we have discussed, alcohols and solubility. Then we have started with the chemical properties. So in chemical properties, what all we have discussed in chemical properties, we have discussed how the alcohols are acting as a nucleophile and how they act as a electrophile. Okay. So in case of nucleophile, what will happen? The cleavage or the bond breakage will take place at OH bond. Okay. And in case of electrophile, the bond breaking of bond takes place as CO bond. So we have seen two types of groups. So first we have seen a reaction involving the cleavage. Okay, that is the breaking of bond takes place at OH bond. So first is with the reaction with metals. So we have seen the reaction with metals. Then we have discussed about the acidity of alcohols. Okay, we have discussed about the acidity of alcohols and how the alcohols is weaker acid than water. So what is the reason? So these all things we have discussed. So next class we are going to discuss about the effect of substituents, that is electron donating group on alcohols. Okay, and then acidity of phenols, Okay, so these things we'll be discussing in the next class. Any doubts up to here? Yes? Any doubts you have up to here? Okay. So, yes, any doubts? No. Okay, fine. So, I'll end the session here. Okay, we'll meet in tomorrow's class. So, in tomorrow's class, we'll be discussing the remaining things. Okay. So, thank you. Thank you, dear students. So, we'll meet in tomorrow's class.